Okay, hello everyone and welcome. As Cal said, my name's Vicky. I'm a science teacher here at InterHigh. The session I'm going to teach you is normally aimed at Year 8 pupils, but it doesn't matter if that's not your normal year group. I hope that you'll enjoy it, you'll learn a little bit of science, and you're going to find out all about lessons and what we're all about here. First of all, could you just use the little raise your hand button and just raise it just to let me know that you can hear me okay? That's marvellous, thank you. Okay, looks like I'm coming through loud and clear. Excellent. You can put your hands back down again now, everyone. Thank you. So, we would normally start with a slide that looks a bit like this, and it tells us a bit about what we're going to be learning about in today's session. The title is anaerobic respiration. Some of you might know a bit about this already. Some of you might have never heard of these words before. That doesn't matter at all. And the big idea for today is we're thinking about cells in living things. We're made of cells. All living things are made of cells. Can our cells do without something called oxygen for a while? So by the end of the session, hopefully you're going to be able to describe the process of anaerobic respiration. You're going to be able to give something called a word summary for it. And we're going to find out a little bit about an oxygen debt. Now, I'm going to start off with a practical demonstration, which hopefully is going to go okay. So I've got a little flask here, and it's called a conical flask, and in it I've got some water, and I've put some sugar inside that conical flask. Okay, and so I've got some warm water. You might be able to see it's warm because there's a little bit of condensation that's appeared. Now I've got a living thing, and the living thing that I've got is here. It's called yeast. You might have used this yourself. You might have do a little bit of baking. And I am going to put, so I'm just going to get a poll into the room. So you guys are going to make a prediction about what's going to happen in my demonstration. Okay, so I'm going to open up the poll. So I'm going to put a teaspoon of my yeast. Yeast is a living thing. It's made of cells, just like us. Except unlike us, it doesn't have trillions of cells, it's just made of one cell. So I'm going to put a teaspoon of yeast into my flask. Okay, so I'm going to just show you, hopefully not tipping yeast all over the place. So, a reminder, the yeast has some warm water, it has some sugar, so that's glucose, some sugar, and it's got air, it's got oxygen in the air available to it. And then I'm going to do something really strange, because the last thing I'm going to do is, I'll do this on my desk and hold up, I'm going to put a balloon on top. Okay, so lots of people started to answer the poll already, which is great. I'm going to pick a few answers. So before I'd even put the balloon on top, I started to get some answers like, it will grow, it will dissolve into the water, it will bubble up and rise. So that's interesting. So I want, if everybody can answer the poll, you can put, everybody can put a prediction in. Lots of people suggesting that this balloon might expand. Some of you saying with air. Okay, we're going to visit this idea in a minute. Now, I'm going to put that to one side, and we are going to do a little bit of learning in the classroom in the meantime. So if you haven't added anything into the poll in the meantime, that doesn't matter at all. Okay, but if you have, that's great, because I'm going to put this to one side, and we're going to return to it in a minute. Now, I've got a little bit of yeast on my desk, so I'll get rid of that. Now, we have been thinking about living things so far, about this living thing called yeast, and if this was a science lesson normally, I'd have taught the pupils about something called respiration. And lots of you will have heard of that word before. But because I've never met lots of you before, I'm going to tell you a little bit about this process called respiration. So, I've got a little animation here. And Cal, could you confirm for me that you can see the animation okay on the screen share?
Yes, you can see the animation.
Great. So what is respiration? Well, our bodies, as I mentioned, just like the yeast, are made of cells. And you can see in the picture here, we've got some cells. Normally, our cells need to get energy. Energy is really important. It's what allows us to move about. It's what allows us to keep warm. It allows our cells to do all the things that keep us alive. And in order to get that energy, a thing called a chemical reaction occurs inside the cell. And we can see at the top a little bit about that chemical reaction. It tells us that the cell needs a couple of key things. One of them is glucose, or sugar, like I put in the flask. One of them is oxygen. And I'm just going to bring the chat pod in really quickly, and I'd like you guys to tell me, how do you think you get the oxygen inside your bodies so that your cells can do this process of respiration? So hopefully you get some answers on the chat pod. By breathing, yeah. So we normally take oxygen in by breathing it in. Excellent. And the air around us contains the oxygen. But the oxygen's then got to get to the cells. So we've got to get that oxygen from our lungs all the way to the cells. And we've got trillions of cells in our bodies. We've got cells in our little fingers, in our little toe, all over our body. So how does the oxygen get from our lungs all the way to the cells? Oh, there we go. Iman, you answered my question before I'd even asked it. Yeah, there we go, through the blood. Excellent. Well done. I can see we've got loads of great scientists here today already. Now, in my little animation, you can see that there's a blood vessel here. That's represented with these kind of red blobs. And can you see how the blood vessel is passing by the cells? As it passes by each cell, it drops off both of the things that the cells need, the glucose and the oxygen, and it also takes away a waste product. We can see that waste product labelled here as carbon dioxide. We're now going to think a little bit about what the cell is actually doing with those things. Now, inside a cell, cells are amazing. They're like little factories inside your body, and parts of them are called mitochondria. Some of you may know this already. And what they're doing is they're taking the glucose and the oxygen, and they're basically turning it into energy in this chemical reaction. There are a couple of waste products, carbon dioxide and water, which need to be got rid of. Here's a little animation showing the glucose and the oxygen combining, and the carbon dioxide and the water getting formed. And then if we go back to the first diagram, we can see that the cells get rid of their carbon dioxide, and the water is quite useful. So quite often cells keep hold of some of that water. So we know that we need energy. We know that our cells are able to produce energy using sugar and using oxygen from the air, and we get that oxygen by breathing in. What do you think we do with the waste product carbon dioxide? So what do you think we do with the waste product carbon dioxide? Fantastic word there, Jemima. Brilliant. We breathe it out, we exhale it. Good. We basically breathe it out into the atmosphere. We can prove this. If you hover over the left-hand side here of this clip that says YouTube, you can see a person blowing through a straw into a substance called lime water. And lime water is a test for this gas, carbon dioxide. And when lime water meets carbon dioxide, it turns cloudy. So have a little look at the clip and tell me, what evidence can you see that a human or a living thing produces carbon dioxide as a waste product? What can you see happening? Watch the clip if you haven't already. It's just about 20 seconds long. Do you want me to, I can share it again, Tracy, if you click on it. You can either click on it from the screen, or you can, there we go, so it's just here, and also if you hover your arrow over the link on the screen, you should be able to see it as well. So hopefully some of you have seen. So yeah, the lime water turned a milky colour, didn't it? So there we've got proof of the fact that we're getting rid of carbon dioxide. The lime water is a test for that gas, and we can see that that lime water turns cloudy when the carbon dioxide gets bubbled through it. Sorry, Tracy, if you hover over the clip on the screen, it should also work. Okay, hopefully everybody had a chance to have a little look at that clip and to see that there is proof that when we breathe out, carbon dioxide is being produced, and that there is evidence for that because we can turn the lime water cloudy. Okay, so let's see how much we've remembered so far. I'm going to get you to take part in a poll. The question is this. That process that we've just seen was called respiration or aerobic respiration. And I'd like you to look at the 3 boxes on the board and tell me which one you think is the correct word equation for aerobic respiration. A minute, right. Okay, so some of you've chosen the first one, glucose plus oxygen gives water and energy, but remember we saw evidence that carbon dioxide is produced in respiration when the person was blowing through the straw into the lime water, so we know there must be carbon dioxide there as well, so it can't be the first one. Then if we look at the second one, glucose plus energy gives carbon dioxide plus water. Well, we know we need to take in oxygen. Our cells need to gain oxygen in order to be able to carry out this process. So it can't be the second one. Therefore, if you chose the third one, that must be the correct one. Glucose and oxygen in our cells combine, and when they do that, we get a couple of waste products, carbon dioxide and water, and we get energy, which is the whole point of the process. That's what allows our cells to do the things that keep us alive, to keep us warm, to help us move about, and to do all sorts of other chemical reactions that keep us alive. So, we've thought a little bit about how we get energy. But what about times when our body doesn't have very much oxygen and doesn't have enough to carry out aerobic respiration? Sometimes if you've been exercising really, really hard, it can be difficult for your body to get all the blood around to all the cells. You probably experienced that when you exercise really hard, your heart has to work hard to pump all that blood around. Your lungs have to work hard. You're breathing in and out really quickly. And even then, it can be difficult to get the cells the oxygen they need. And yet, cells constantly need to get energy, particularly our muscle cells if they're working hard. So, is there a plan B? Basically, yes, there is. Now, if I draw an outline here, we have a picture of a cell. This is a simple diagram of a cell. It's a bit like the cells in your body. You can see there labeling the parts. Some of you who've learned about cells before will recognize these parts of a cell. We have something called a cell membrane around the outside. There's a nucleus in the cell that controls the activities. And there's the cytoplasm, which is the jelly-like substance in a cell where all the chemical reactions occur. Now, normally, as we saw in the animation, glucose makes its way into the cell. That's represented with our little triangles. I'll draw a few extra. And normally, oxygen makes its way in as well. But if we're exercising too hard for that oxygen to get to our cells, this cell isn't receiving any oxygen. Now, in order to be able to gain energy, the cell's got to have a backup plan. It's got to have a plan B. And that plan is called anaerobic respiration. Basically, what the cell does is it breaks down the glucose without oxygen to release energy. And instead of the chemical reaction that we just saw, we've got a different chemical reaction, this one here. Glucose gives lactic acid and a little bit of energy. It's not as efficient, it's not as good as aerobic respiration. So it's only a short-term plan. That's why you can only exercise really, really hard for a certain amount of time before you have to stop. Those of you who've been in lots of workouts at home will probably have realized you can't keep going forever. If you exercise really hard, you have to stop. And it's because our cells can only rely on this backup plan for a short while. Not all of the energy gets released from that glucose molecule. The lactic acid that's produced still has quite a bit of energy locked up in it. And so our muscles can't do anaerobic respiration for too long. And if too much lactic acid builds up in the muscle cells, it's also called lactate, then it has to be oxidized. It has to be got rid of. How do you think that your body eventually gets rid of the lactic acid and oxidizes it? Any ideas? Have you been doing anaerobic respiration because you've exercised really hard and you've not been able to get enough oxygen to your cells? Yeah, Phineas, breathing. And you'll notice athletes, after they've finished a race, they're often breathing really, really hard. And that's because they have to pay back what's called an oxygen debt. So whilst they've been exercising really, really hard, their cells don't get the oxygen they need.
Yeah, the Q&A pod has been very quiet, so if people do have specific questions, we can obviously put those into the Q&A pod just by typing into the space at the very bottom.
Water that way, but it doesn't help to remove the oxygen debt. So, Cal, is there anything to pick up on the Q&A pod or any questions that have pinged through? Don't forget you can post on the Q&A. Yeah, go on. Brilliant. Thank you, Cal. Yeah. So don't forget, if you've got a specific question or if you didn't understand anything, you wanted to go over anything, that's absolutely fine. So let's recap where we've got up to. When you stop exercising, you continue to pant, you continue to breathe hard because your body needs to use oxygen to break down the lactic acid that's built up in your cells. And we call this the oxygen debt. Here's the equation for anaerobic respiration in humans. And there's a reason why I say in humans, because there's another living thing that we're going to look at in just a moment. So lactic acid has to be broken down. It can't stay in our muscles for too long. And it has to be broken down by oxygen to allow the muscles to return to normal. That's what we call the oxygen debt. So let's see how much you've remembered again. Let's have a poll question now. I'm going to open this up. The question is, what are the products? Have a look at these. I can see we've got a hand up. So, Aban, it might be that you wanted to speak over the microphone. I'm quite happy to, if anybody's got any questions they wanted to ask over the microphone, that's absolutely fine. It might just be left up from before, but just we'll come to you, Aban. If you've got something you wanted to ask, please go ahead while everybody's answering the poll. Oh, I think you're a bit quiet there. Couldn't quite hear you. And I've also got Chris. So, Chris, if you wanted to ask a question, go ahead. Oh, quiet at the moment. Okay. If you've got your hand up and you'd like to ask a question, that's absolutely fine. We can see if anybody's got questions. So what I'll do for the time being is just disable microphones for a minute and then come to some questions at the end. So if you've got a question you want to speak over the microphone, leave your hand up, and there is a little microphone tool at the top that you can use to speak over the mic. Okay, so I'll go through this task here. So what are the products of anaerobic respiration? Let's see if we've remembered. So one of the possible answers was carbon dioxide and some energy. We don't produce any carbon dioxide when we do anaerobic respiration. That's only aerobic respiration. The second answer, lactic acid and some energy. That's been the most popular one. And the third one, carbon dioxide and lactic acid. So it is the middle answer. Well done. Lots of you chose that one. So it's lactic acid and some energy is are the products of anaerobic respiration in humans. Okay, I think it's time to come back to my demonstration. So humans have a plan B that they can use, but there are other living things that can carry out anaerobic respiration. One is quite useful to us. Here we go. My experiment has started to produce some results. We can see a couple of interesting things have happened here. So I'm going to bring back the predictions. You can have a little look at your prediction. Was it correct? Some of you said it will fill up with air. Okay, so if we bring the chat pod in, do we think that was a correct answer? What do you think? Do you think that balloon's full of air? Got some yeses and some nos. Okay, let's have a look at the information that's on the slide. Yeast is able to carry out respiration, both aerobic and anaerobic. And yeast always produces carbon dioxide. Unlike humans, where we only produce carbon dioxide when we do aerobic respiration, yeast always produces carbon dioxide. And that makes it really useful because those bubbles of carbon dioxide gas, which at the moment have risen, the gas has risen up and inflated the balloon here, they normally can make bread rise and expand the dough in bread. So when you use yeast to make bread, you're in fact making use of respiration, both aerobic and anaerobic respiration in yeast. And the yeast cells, the glucose is in the yeast cells, the glucose is broken down into ethanol, a different substance to lactic acid, carbon dioxide, and there's a little bit of energy produced as well. And actually my flask, although you guys can't feel that, has become quite warm because of all the energy that's been produced.